everyone. We're going to determine whether the series converges absolutely, converges conditionally, or diverges. So let's use the limit comparison test first to see if it converges or diverges. Both series converge or both diverge. So doing that, we're going to let a sub n equal what we have. We'll just let that be 1 divided by square root of n plus square root of n plus 1. And b sub n, we're going to let that equal 1 divided by square root of n. So using the limit comparison test, we're going to have c equals the limit as n approaches infinity of a sub n divided by b sub n. So a sub n is going to be 1 divided by square root of n plus square root of n plus 1. B sub n is here, which is we're supposed to divide. Instead of dividing, let's multiply by the reciprocal. So that's going to be, let's put the square root of n here and divide it by 1. So that's what we have. All right, from there, let's go ahead and evaluate the limit by dividing each of our terms by square root of n. So that's going to give you 1 divided by 1 plus square root of 1 plus 1 divided by n. All right, and then after that, basically this piece here is just going to, we're dividing both of those by n, by the way. So basically, this is just going to go to 0, and you're going to get 1 plus 1 plus 1, which equals 1/2, which is greater than 0. All right? So that tells us that either both of them converge or both diverge. So looking at our comparison here, we have b sub n equals 1 divided by n to the power 1/2. So p is less than 1. That means it's divergent. So our series is not absolutely convergent. So now let's see if it's conditionally convergent by using the alternating series test. So for that, we need to check for conditional convergence. We'll let u sub n equal 1 divided by square root of n plus square root of n plus 1. And this is going to be positive because of our square roots there. So that checks. Now we have to check and see if it's decreasing. So let's look at this. We have square root of n plus 1 plus the square root of n plus 2 is greater than square root of n plus square root of n plus 1. Therefore, 1 divided by square root of n plus 1 plus the square root of n plus 2 is going to be less than 1 divided by square root of n plus square root of n plus 1, because this denominator is bigger than this denominator. So that means we have a decreasing series. And now let's check our limit. So if you do the limit as n approaches infinity of negative, or just put 1 divided by square root of n plus square root of n plus 1, that does equal 0. All right, because it's going to get closer and closer to 0. So let's put equals 0 there so you can see it better. All right, therefore, this is conditionally convergent. And that's it. Thank you. Have a nice day. Bye-bye.